Yeah, so hi everyone. It's good to see you again. Today we're going to talk about inequalities in one or two variables. We're going to do most of the hard questions on the final page. We've already done the easy ones in the first 15 minutes of the session. This is more of an applied skill. So it's not a skill where you have some theory and you learn it, at least some very basic theory, like we have, for example, with linear functions. If you talk about linear functions, then you have these certain properties which define it, so you need to know this beforehand. But here, I don't really think you need to know anything beforehand, except for the previous knowledge from these other skills. So that's why I say it's applied. Linear inequalities in one or two variables is just linear equations in one or two variables with a twist. And today we'll take a glimpse at that. So let me start sharing my screen. Okay. I think it's shared now. And we can start. So I'll start with this problem and I'll give you 60 seconds to attempt it. Clock ticking. Yeah, so if you know English, then probably you have a very good chance at solving this question. You know English, right? So it's like maybe it's the time constraint, so that's because I'm saying 60 seconds is pressuring. Well, the 60 seconds are up, and we can talk about it. So you have a number. It is at most. So at most means it is less than or equal to. I hope that is intuitively clear. So at most is a Q. Yeah, it's a Q for you. It means less than or equal to. This number is less than or equal to. It's not less than or equal to 3 times the value of y. It's less than or equal to 2 less than 3 times the value of y. So if you read it from right to left, then it's probably a bit easier to see. So you start with 3 times the value of y. Okay, that's 3y. And then you go 2 less, so minus 2. And then x is at most this value. So it is less than or equal to this other value. Now, if y is equal to minus 4, then can somebody tell me what x would be? Yeah, x is less than or equal to minus 14. So my tip here is really just to read the right to left.
Do we need the less than equal to sign? Equal to sign? Do we need the less than or greater to equal sign? It's like an equal to sign?
Yeah, I was going to talk about this in a moment. So this is actually correct. It might be at first intimidating. Hi, good to see you. It might be intimidating, but it's really just the same thing. It's really just the same thing, with some caveats. But we will only discuss those when we need to, in order not to have things outside of their right context. But at least for this problem, it's not too difficult. So if you read it from right to left, then it is more easy to understand.
So just to be clear, the greatest possible value of x then would be minus 15, correct? Because it has to be less than or equal to minus 14. Oh no, I guess because it has to be equal to, so it can be minus 14.
Yeah.
Yeah.
Okay, no, it's actually less than, it's not equal to. Because it's less than. It's 2 less than.
Is at most, so yeah, it can be.
So the greatest possible value of x is probably 13 if x is an integer. I mean, the answer sheet says that it's 14. Then maybe with good intentions, we can just assume that it's less than or equal to, and then minus 14 is the answer. If that makes sense. Yeah, so that's it for this question. Maybe we'll do another one. I have to choose one of them. I like this one. I don't know if there are any HCE majors here. Okay, there's one.
I take electrical engineering course.
Yeah, okay, good thing with engineering. You know what this thing is? Yeah, I mean, you don't need to know what it is to solve the problem. You have 60 seconds to do it. By the way, I'm just talking, I'm wasting the time. You need to start solving it now.
Like I never saw any electrical engineering question. Let's get here.
Well, guess what? There is. Yeah. No, this is from the SAT College Board. I didn't make this up. I didn't make this up. I can show it to you. This is the code for it. If you Google this code, you get the question. It's from the question bank. You've just wasted 30 seconds. You have 30 seconds to solve it. Get going. So for this problem, it's really just about applying your givens. But to apply your givens, you need to write down all of your givens. So maybe that's a hint. Please. Okay, time's up. I mean, you could still try to do it. I mean, I'll just start now. So what basically happens is I give you 60-second head start.
And actually have the curve
first. Right? Yes. So the first thing I would like to do is to start writing down the givens. So the current is, what is it measured in? Right? I think by the current you mean the potential difference.
Okay.
Or no? No. You mean the You mean the I.
Resistance is given.
Yeah. So resistance is given. How about this? Let's try to write down all of our givens one by one. So to start, the circuit has a resistance of 500 ohms. So this is the resistance R. So R is equal to 500 ohms. Okay, I don't need to write the symbol. It's not ECE, so it's fine. So R is 500. what else? So the potential difference is generated by n 6-volt batteries that produce a total potential difference of 6n volts. So the potential difference, which is V, is 600. No, I'm sorry, 6n volts.
6n.
Yeah.
So it's 6n over 5.
I. Okay. Yeah, that's I.
Yeah.
Sure. So you want to say that I will always be 500 divided by 6. Ah, yeah, I mean, I'm not a physics major.
Yeah.
So maybe that's a fair answer.
And then you can solve for it.
Yeah, let's not speed up here. So let's make sure we understand this. So the electrical current intensity depends on the number of batteries that you use. So if you use one battery, you get 6 over 500. If you use two batteries, you get 12 over 500 amperes. If you use 100 of these batteries, then you have 6 over 5 amperes of current. So just to make sure we actually understand what's going on. Now, is this clear?
Yeah.
Yeah. So we have this result. We see that the intensity depends on n. So that's a good start. Now let's go on and read the rest of the question. It says that the circuit is to have a current no more than 0.25 amperes. So amperes are related to I. I is the quantity in amperes. So we would like I to be less than 0.25. Because we said no more. Now, so let's also emphasize it. So no more means that it is anything that is less than 0.25 ampere. This is good. So from here, we get this other fact. So we started with two facts. We got a third fact. And then by reading the problem, we have a fourth fact. Now, how do we conclude? To not be too difficult to conclude. These are the numbers, numberings for the facts. These are not constants or anything. So what you would do here is you would combine 3 and 4. Here's what I mean by this. So I is less than 0.25 on one hand. On the other hand, I is equal to 6n divided by 500.
Big N is 20.
Not sure, I'm not a calculator. So what I mean to say is here is that I, maybe I'll use some coloring now. This coloring is nice. Green is nice. So I is 6n over 500, and I is less than, that's not the idea. And I is less than 0.25. Then I can remove I, and I can put in 6n divided by 500. So that is the idea. And now I have an equation n, which I can solve. I think Wissam has already solved it.
I think it's 20.
So if we just multiply this by 500 over 6 on both sides, then now, like Singh just pointed out a few moments earlier, we treat this as a normal equation. There's no issue with that so far. And so when we do this, we get that n, because this is the multiplicative inverse, cancels out, and you have n is less than 0.25 times 500 over 6, which is said it's almost 20.83.
Yeah.
20.83.
Yeah, exactly.
So this is a sign for approximation. So you use the tilde for approximation. That's okay. Now, what is the greatest number of 6-volt batteries in that case that would not let us exceed 20.83? You need an integer number of batteries. It tells you to use less than 20.83 batteries. So what is the most number of batteries that is still less than 20.83?
Isn't n the number of batteries?
Yes.
So it's 20.83 batteries.
Yeah, but you cannot just take a battery and just
Yeah, 20
divide
or 21.
20 and 21. What do you think? I mean,
If we round it up for 21, then it will exceed 125. We cannot do that.
exactly.
So it's 20.
You see, because if we plug in, so n needs to be less than 20.83, and so let me write this, and n is an integer. Therefore, n is an integer that is less than 20.83. Therefore, n is equal to 20. So because it's less than, you go one step backwards. You go one step forward, then it's problematic. So I hope that was fun. I don't know.
Yeah.
I don't know. And now I need to choose another question. I like this one, so why not do it? You have 70 seconds this time. I'm being generous. 7-0. 17 would be too little, you know? Okay, let me try to solve it in 17 seconds. I couldn't solve it in 17 seconds.
We can solve it.
Yeah, but my advice for you is to at least start writing some ideas, some scribbles, some stuff. It's all very useful.
I don't know if my idea is right. Or probably skip it.
No, I know the answer. What do you mean? No, I know the answer. Like,
If it came in the exam, I'll skip it and come back to it.
if it comes in the exam for you, yes. I mean, probably. It's not the type of question where you look at it here and say, that's 3 over 2. So obvious, right? Now I'm being sarcastic. What do you think, Eosius? What do you think? No, I'm talking to Eosi.
Wait. Sorry, what did you say?
What do you think of the problem? You can see my screen, right?
Yes. Wait, give me a second.
Of course.
think like
What do you think?
I just think that 2x and minus 12x is like it's gonna be minus 9x. Minus 10x, minus 10x.
Okay, so y is greater than minus 10x greater than 5.
So we still have like we should choose that's y is bigger than the other numbers. So I don't think the it's like we're gonna do I mean 75. When we reach this type of
It's a distraction, guys. It's a distraction.
yes,
Minus 10x is a distraction.
right?
Where's up?
Yeah.
You see it?
Uh,
It's a distraction.
2x minus 12x is distraction.
The 6. So yeah. So that's what I'm trying to say.
So is it D? I think it is D.
Yeah,
Okay.
because y is greater than 2x. It doesn't matter what it's greater than 2x minus 2x minus 12. It doesn't matter.
Okay, 2x minus 12x bigger than 5.
It doesn't matter because y is greater than
Well,
5.
we don't need X, right? In this
We don't need it.
situation. Yeah.
It's just a distraction. You guys.
We only know that Y is greater than 5.
Yeah.
Which means it can't be like less than 5. We cannot say it is greater than 4.
Yeah, exactly. Exactly. Okay, I have a good idea. Let's.
What I did is I plug it in this one and check which shaded area equals more than 5 for both x and y. It was v.
Yeah, exactly.
Okay, how is it?
Because if y is greater than 6, then 100% with 100% probability, y is greater than 5.
Yeah.
That's what it means.
So we're playing probability game in this.
No. So when I say probability 100, I mean like with 100% confidence. This is just a word thing.
Since x is greater than 5 and y is greater than x, so it's more than.
So here's the thing. So y is greater than 2x minus 12x, and then this is greater than 5. Do you agree with me that this would immediately imply that y would be greater than 5?
Yes.
Okay, now you would like instead of all y. Okay, no, you would like one of these 4 choices, which satisfies this property.
Okay.
We would like to choose a group of y's which satisfy this property. So if you choose y is equal to 4, then does this mean that your y will be greater than 5? If you choose a number that's greater than 4, it doesn't have to be greater than 5. But if you choose a number that's greater than 6, then 100% it is greater than 5. And so from there you reach the solution. You don't need decimals for it.
The issue is I saw it y is less than 2x. I didn't see it's greater, so that's why I was using.
Okay. Maybe one time I'll bring you up here and you'll just
No,
give us a
actually,
tutorial.
it takes like 10 seconds.
You'll give us a tutorial on decimals because you're the expert in decimals. You're a decimals enjoyer. So y greater than 6 implies that y is greater than 5. Because if a number is greater than 6, then it is greater than 5. And that is really what I'm trying to say here. This is an ambush, maybe a trap, whatever you can call it. So that's why I like this question so much. Okay, maybe not so much, I just like it. So that is something. This is standard. This is a good problem. It has a nice balance. So I'll give you, yes, I'll give you 70 seconds to attempt it. And my advice for you here is to write all the givens. So start by writing down all the givens and then see where this takes you. In the SAP, you want to write as fast as you can, of course. With 70 seconds on the clock, that should probably be your strategy as well. You have 8 seconds. Think. Yeah, and I think I can start writing down some stuff now. Not the solution, but some stuff. Okay, so we're talking about the shipping service. There's a restriction on the dimension of the boxes. Okay. What's the restriction? It says that for boxes shaped like rectangular prisms, the sum of the perimeter of the base of the box and the height of the box cannot exceed 130 inches. That's a tongue twister. I don't know. You can actually read that and extract any useful info. So for that, if you are talented enough to draw this very accurate drawing of rectangular prism, then you then have some thoughts about it. So the sum of the perimeter of the base of the box, let's call it P, and the height of the box, let's call it H. By the way, it's a really good practice to name your variables according to the objects that you're using. It's very useful. It helps you make progress faster with the problem. So the parameter and the height, their sum, cannot exceed 130 inches. So cannot exceed means P plus H is greater than or less than 130.
Less than or equal.
That's our equal. Yes, so it cannot exceed. So it's not greater than. It's less than or equal to 130. Okay, that's looking good. So that's one fact already. Now, there is another statement about the parameter. The parameter is determined using the width and the length. Yeah, okay, I didn't know that. Wow. So the base is probably this, probably length and the width. Maybe, I mean, it doesn't matter. And the height is probably this, this part. I mean, you don't need to draw it to understand it in the exam. You're just doing this for illustration. Now, what do we know about the parameter? Here's what we know. So it says that if the box has height 60 inches, oh no, okay, let's go on. So the height, so the box has height 60 inches. So the height is 60 inches, and the length is 2.5 times the width. So do you see how I've translated this word problem into useful info?
We did that exactly.
You know how to do it in decimals?
Hmm.
Probably you should focus on it. Anyway, I'm just joking. So here's what you should do. you have this fact, this fact, and that fact. Are we out of facts? I think so. So the length is 2.5 times the width. And now it's asking about the inequality, which shows us the allowable width. Here it calls it X, but we can just call it W, just for the sake of our understanding. Okay, so we need to find an inequality in W. So we remove everything else, and we just place in W. Now, do you have some idea on how to combine these three facts? You don't need to combine them all at once. Some sort of magician, you just need to start slowly. And there's an easy way to start with this. So the height is 60 inches, and the sum of the parameter and the height must be less than 130. So I can simply combine 1 and 3 to get that P plus, well, instead of H, I'm going to write 60. Is that okay? Okay. And this should be less than or equal to 130. Okay. What's the parameter of the base of a rectangle? Two. Yeah. Yeah, twice the length plus width. I hope this is not the first time you see this. Okay, so this might be a fourth fact even. But that sounds good. This is what we have. And we were stuck here until we were able to write down a formula for P. When we did this, then I can combine, okay, if I call this 5, then I can combine 5 and 4. And I would replace P with twice length plus width. So we're almost there. So twice the length plus width plus 60 is less than or equal to 130. Maybe I'll use some more coloring to make sure that what we just did is very, very clear. Okay, so we're almost there. We would like to have an inequality in W, but we have L and W. So we need to get rid of L. Now, how do we do this?
2.5 W plus W.
Yeah, so L is equal to 2.5 times W. By the way,
So it's 2.5
Yeah.
W squared.
don't think so.
Plus
It's 3 point.
Yeah, we'll see. Yeah, we'll see in a moment. But here's what I want to say. So if you don't know what to do next, you can look at your givens. And let's say we don't know what to do with L. We don't know. We have used up this fact. We've used up this one. We've used up that one and that one. And we've run out of facts, except for this one. Then if you're on the SAT and you need to solve the problem, then look at your givens, see which one you still have not utilized yet. And then when you identify this fact, then you can utilize it. And so we will do exactly just that. Let's call this equation 6. If I combine 6 and 2, I can replace L with 2.5 times the width. And I'll do just that now. So that's L. I'm taking twice of this whole thing. And that's amazing because this is an equation, okay, an inequality in one variable. And it is my variable of choice, W, which I'm looking to find an inequality for. So I probably just need to simplify it. And if I actually do that, so you just take away 60 from both sides, you treat it as an equation, you get 70. And then if you add 2.5 W, and then you add 1 W to it, so you get 3.5 W. So there's no square.
No, I thought it was multiplied.
Oh no, it's not. There's an addition. But I hope,
Just that.
yeah, but I hope that makes it clear. So here we get 3.5 W times 2 is less than or equal to 70. Now 2 times 3.5 is 7. We have W, and on the other hand we have 70. Then in that case, if we divide by 7, you get that W is equal is less than 10. And of course it is greater than 0, because if you're measuring the width of something, it cannot be a negative number. And so from there you obtain that this is the solution to the problem. So it's a bit lengthy, has many ideas. And the key takeaway really here is to use your givens and to always utilize them, to always have them in mind. If you're able to do this, and if you're able to formulate your givens properly and apply them, then doing a problem like this one should not be a huge issue. Are we going to do this problem? Yes, why not? Let's do it. So I will give you 70 seconds because I'm feeling generous. So, we should start doing the problem. I'm sorry, by the way. I know that all the problems that I choose take 17 seconds to read because they're very long every single time.
That's the hard part.
Yeah, so these are the hardest questions you face. Twenty seconds. So just write down all your givens and start from there. Yeah, time's up. And you can still attempt the problem.
It's D.
D already. So Wissam says
D.
D. Does anyone else have any
D.
answers? Okay, Omar says.
That's in the
Omar also says. That's D. Okay. So I'll keep this until the very end. So we'll see if your answer is correct or not. Now let's read the problem and try to extract some data. So it talks about some sort of psychologist who made an experiment. 300 people were presented with a set of 5 pictures.
Can I change my answer?
No.
B.
Okay, I'll let you do it. So it's
I'm still looking at you.
I mean 25%, right? Yeah, anyway. So 300 people presented with a set of 5 pictures, and each person was asked to choose the most appealing picture. So these 300 people are there, okay.
They choose the first picture.
Hmm?
They all of them they choose the first picture, and the 150 participants in the first 150, 36 of them they choose the first picture, and 150 the other 150 they all of them they use the first picture too. It's like gonna be the half. It's like 150 minus 36. minus 150 minus 36, so it's gonna be like 124.
14. 14. This is what you mean.
114.
Um,
And then it's like 114, and they showed another picture, I guess, 5 pictures. And 36, the first 36, they showed the first picture, but not the all 150. So it's like subtract the difference 150, and then see the value of B. So it's gonna be. I don't know what I'm saying.
all this time, it sounds like you know what you're saying.
I don't know.
Well, it's fine. It's fine. You try, and that's the most important thing.
It's like saying.
No. I get you. So, out of these 300 people, they're divided in 2 groups. You have a group of 150 people
Yeah, it's that what you're saying.
and another group of 150 people.
36 of the 150 did choose the first picture.
So let's I'll make something like an index here to count the people who chose the first picture.
Yes, it's like 186.
Oops. So in the first group, 36 people chose the first picture. Now for the other 150 people chose the first picture.
Okay, so 36 among of the 300.
No, 36 out of the first group, which is 150.
Okay,
And then for the other group, P people chose the first picture.
so it's like to the if more than he said if more than 20% of all the participants choose the first picture in the set. So I guess it's like we will take
So here's this.
50 over 100 times 20.
Mm-hmm.
That's right.
Let's see. So I want to ask you guys a question. So in the first group, we have 36 people who chose first picture. In the second group, we have P people who chose the first picture. Then how many people out of the 300 people that we have chose the first picture? 36 plus P. Is this okay?
Yes.
So the total count of people who chose the first picture is 36 plus P. This is good.
Yes, I would.
Okay, and now what's the final fact that we still have not discussed yet? It says that more than 20% chose the first picture. So this 36 plus P with respect to the whole 300 is more than 20%. Or if I reformulate this,
Yes.
more than 20% of all participants is, I can say 20% of all participants, so 20% of P. Now, if I call this sigma 1, so the count of people who chose the first picture, this is just notation. I hope it's not scary.
But it's 20%.
Hmm?
20% of 36%.
Okay, if it's
Not
30,
three, I don't
if we take it from 36, we just like.
So what I want to say, yeah, if you're saying something.
Yes, if we take 20% from the 36, so we would just take from the first 150. We don't take it from all the 300.
Yes, that is
Just
true.
adjust adjust the P to get the answer of P. So
Yeah,
we
you
don't
need
take
to
it from
adjust.
36. We will take it from the other 150.
Uh-huh.
Yeah, it's all participants.
It's all the participants.
So it's on 20% of P plus 36.
No.
No, I meant here. So okay, I'm sorry. This must be a confusion. So I meant big P. Okay, so I'm sorry. Okay, that is the problem. So do not choose the same variable twice. Not do like, okay, just, okay. Another letter. Mm,
Okay.
K, I like K. Okay.
No.
No, I still haven't written down my statement. So what I'm saying is that 20% of people, more than 20% of people chose the first picture. So more than 20% of people.
Yeah, I guess just like 300.
Chose well, sigma 1 is just 36 plus p, right? So more than 20% of all people. Why am I writing k? Why don't I just write 300? Yeah. So 20% of 300 people chose 36 plus p. Okay, more than.
60.
So the answer is still not clear to us. Let's see what we get. So 20% of 300 is 60. So 60 people. Yeah, so 60 people chose 36 plus p. More than 60 people. So you have more than 60 people who chose the first picture. But the 60 people are 36 plus p. Now, what I'm writing here is not the solution. I'm just writing some ideas down. I'm
Yes,
showing you my full thought process. This is not at all rigorous.
60 minus 36.
Yes, that is what I mean. So 20% of the whole people in the experiment is 60 people, at least. So if I want to find p, it's 60. It's not 60 minus 36, but okay. So that's at least 20%. 36 plus p is 20% of the people. So that's why I should take away 36. So that is actually correct.
Is it clear for now that it's C?
Yeah, because p plus 36 is the number, is my sigma 1. It's the number of people who chose first photo. And I'm saying that the number of people who chose the first photo is greater than 20%
Yeah.
of the whole population which carried out this experiment. So that is what I mean. Yeah. So sorry, Sam. Sorry, Omar.
Yeah, I read it that 20% of the 150, not of all.
Yeah, but actually, like, I get this when you type like 36 and K, I'm just kidding.
Yeah. So you count 36 and you count p, then this amount should be greater than 20% of the population. That's what we're really trying to say. Now, perhaps we can do one more problem. No,
No, it's not good.
this is not difficult, actually.
It's more difficult.
This one is good. This one is nice. It has a genuinely good idea. And so I'll give you 70 seconds as usual to attempt it. And there's a caveat here, there's a trick. I'm saying this beforehand. You need to be careful.
So he's just asking the price that the trips they have for per month. Less than 95,
Less than 95.
right?
Yeah, you could say that. Yeah, sure.
Yeah.
So the idea here is to find out when it would be more efficient to buy a ticket, to buy a monthly pass, rather than buying a ticket every single time. So how many trips before I say, okay, I actually need to buy the monthly ticket because it would save me much more money, or at least it would save me this amount of money.
It's the answer to it.
12 already. Okay, let's see. I don't know. The thing says 12. Does anyone have any other suggestions?
That's 95 divided 650.
95 divided by 50.
6.50.
6.5.
Yeah.
So that's really sad. Okay. Would you like to give it a try now? Yeah. So the monthly
Yeah, 14.3.
14.6. Yes. Okay, let's see. So the monthly pass costs $95 to start. And it gives you unlimited access. So it's like a semester ticket, for example. Semester ticket costs $95 per month. And so you want to find out when it would be useful for anyone to buy the ticket, the monthly ticket, other than buying a ticket every single time.
So can you put 14 because you cannot make it 14.6 trips.
Did you say so? So we need to assume this for any individual. And so we assume the worst case possible. So let's say you live, let's say in Albanho.
Can I add my answer?
Yes, of course. You're more than welcome.
27.
27. Okay. So let's say you're situated very far from the university. You're at the Hauptbahnhof, and you always need to buy the ticket for €3.50. If you're living 2 kilometers from the university, you probably don't need to buy the $3.50. But let's assume the very worst case, because that would give us the least amount of tickets. So this is just distraction, and this will become clear in a moment. So it's easy to say this, to just state it. But I think when we do it, it will become more logical in a sense. So we take a look at the trips, which would cost me as someone who's living very far off and I have to pay €3.50 every single time. So I pay, let's say I buy T amount of tickets, and every single time I buy for the amount of €3.50, $3, whatever. Now I want to know when it would be worth it to buy a monthly pass. And so it would be worth it to buy a monthly pass when it costs me to take the same amount of trips, less money. So in that case, it would cost you less. So if this costs you more than $95 or euros, then you say, okay, this is time to buy a pass. I need to buy it. It would save me more money. So let's say, for example, you take 100 trips, then it makes sense to say, yes, the monthly pass is necessary, but we want to find the least such number of trips. And so this is not too difficult. the tricky part is just setting up the equation. Here you just need to divide $95 by the worst case possible. You said 6.5.
Yeah.
I don't know why you said 6.5.
That should be 7.5.
7.5.
If he added them, that should be 7.
Ah, she added them. Well, the trick is here is actually to not use any of them at all. So again, you're going at every single time you come to the university, you need to buy the maximum ticket. And so this is the fastest way you would, how do you say this? You would spend the $95. And so when you do this, do 95 divided by 3.5, and can somebody maybe calculate this for me? I'm not quite sure if the answer is 27. So Singh tells us it's about
27.2.
14. Okay. Then let's be careful. We want the number of trips which the monthly pass costs less.
We want the number of trips, or we but how we need to find the number of trips? How we find the number of trips? So it's like 27.14. So in the one trip, 3.15, right?
Yes, I assume the worst case possible, so I think 3.50.
So it's like we're gonna like time it. No, so it's like divided.
Yeah, so I just divided 95 by 3.50.
No, I just like say 27.50 divided by 3.50.
Again,
I'm not sure. But if we want to find the ticket for each trip, or how many trips, right? We want to know how many trips. So it's like 27.14. In each trip, it's like 3.15.
27.14 is a ratio between.
It's not the total?
No, it's a ratio. The total, the price of the ticket is $95.
Okay.
So you divide the $95 by this quantity that you say, which is $3.5, and so you get 27.1 for trips. So you need 27.14 trips to get exactly to $95. So if you want to go below this number of trips, so you would like to take the maximum number of trips, which would still cost less than the monthly pass, then you would take 27. But if you're looking to take the minimum number of trips for which the monthly pass saves you money, it's 28. So Omar, that's me. I say 28. And there's actually a very easy way to test this. So you can actually just multiply 3.5 by 28. And I claim that this is the first value which will be greater than 95. You can check this yourself. So maybe somebody can check it.
Why 27? Because we are not learning.
28.
This gives you 98. Now, Flavia has a question.
Why is it 28 not 27?
Yes, that's what I was saying. So we want the minimum number of trips for which the monthly pass saves you money. So if I take 28 trips with the monthly pass, how much do I pay? No, if I take 28 trips with the monthly pass, how much do I pay? I pay 95. If I take 1,000,000 trips with the monthly pass, I still pay 95. But if I take 28 trips with the normal ticket, so I just buy a ticket every single time, then I get 98. So 98. So 28 is a threshold at which if you go below it, so if you look at 3.5 times 27, you get 94.5. This is not difficult to see, just take away 3.5 from this. And so this cannot be the answer because it is not, here it does not cost you less to buy the pass, it costs you more, it costs you 50 cents more. But if you start from 28, then you start saving. And if you go on and on and on, if you make 28 more trips per month, then you are better off buying the monthly pass. So that is all I wanted to say for today. Thank you very much for showing up. It's a lot to me. This is the end of the algebra section. So we've done all 5 skills which are necessary to solve any algebra question on the SAT. On Wednesday, we'll start with advanced math. So we'll talk about nonlinear equations. So this should be interesting. So thanks again, and I hope to see you then.